Hurricane Katrina, one of the most devastating natural disasters in U.S. history. More than 1,800 people lost their lives, while countless others lost homes and livelihoods. 5 years later, the waters have receded, but Katrina's legacy remains. Why did Katrina become a Category 5 storm in the Gulf of Mexico, and what made it weaken before landfall? It's questions like this that NASA researchers hope to answer this hurricane season. The Genesis and Rapid Intensification Processes mission, or GRIP, is a field experiment that looks at how tropical storms form and develop into major hurricanes.
This experiment is designed not only to help the experts better understand which of the tropical disturbances will develop into tropical storms or hurricanes, but also help them predict which ones will intensify to monsters and which ones will fizzle out rapidly.
During the 2010 hurricane season, NASA deployed its piloted DC-8 and WB-57 and unmanned Global Hawk aircraft in a massive effort to collect as much data as possible, arming hurricane researchers with the information needed to predict the growth and intensification of hurricanes.
With the DC-8 and in particular the wind LiDAR, we're going to get continuous wind measurements in the environment of the storm, something that we've never been able to get before. With the Global Hawk, the expectation is that because of its 30-hour flight duration, we're going to be able to be out over storms for up to 20 hours or so, which is about 2 to 4 times longer than what we'd be able to do with conventional aircraft. When you're out there only getting very brief looks for short periods of time, it's very easy to miss those critical events. And so with GRIP, we think we have a very good chance of being able to see those processes much more easily than we've been able to do in the past.
Each aircraft brings its own set of expertise. The DC-8, stationed in Fort Lauderdale, carries NASA researchers into hurricanes, allowing them to study the storm from the inside out. It is capable of reaching altitudes of 42,000 feet and is helping scientists with sensor development and verification and studies of the planet's surface and atmosphere. The Global Hawk, this remotely piloted aircraft stationed out of California, is capable of flying at 60,000 feet and is providing information on lightning, wind speed, and other environmental factors in a tropical cyclone. The WB-57, stationed in Houston, Texas, is a high-altitude, piloted airplane capable of reaching the dizzying heights of 65,000 feet. Its instruments retrieve data on the upper atmosphere. This fleet of specially outfitted aircraft will give researchers an unprecedented look inside the mechanics of storms.
The benefit of studying hurricanes with so many instruments at once is that it gives us a more complete description of the atmosphere, both within the storm and in the environment. Within the storm, we want information not only on the winds within the storms, but also the temperature, humidity, and precipitation in the eye wall, and the rain bands. All that information is critical to understanding how the storms evolve.
GRIP will also gather data from a much higher vantage point, outer space. The TRMM, Aqua, Terra, and CloudSat satellites provide data to scientists on Earth, giving them a comprehensive look at storms from different perspectives.
GRIP is designed to take the latest technologies that NASA can bring to bear. Satellites, aircraft that fly in the storm, aircraft that fly over the storm, systems on the ground. Let's put it all out there for 6 weeks and see what we can learn about the physics of these storms.
The flights conducted through GRIP this hurricane season will undoubtedly provide vital information on the life cycle of hurricanes. This information will help scientists predict the birth of potential hurricanes and understand why some tropical cyclones can go from a Category 2 to a Category 5 hurricane in a matter of hours.